Good day, I am Jerisa Argaliana. In this video, I will discuss the inversion using Geogebra. Let us first define inversion. Inversion is a geometric transformation that involves reflecting points in a circle or a sphere. According to Theorem 6.3, the image of a straight line not through the center of inversion under the transformation of inversion is a circle passing through the center of inversion. So there are three main cases of inversion depending on the relative positions of the center of inversion, the object converted, and the circle or sphere of inversion. Let's explore each case. Case 1. Inversion with a point inside the circle or sphere of inversion. So here is our GeoGebra, and let's create a circle. Let's say we have circle at the center 1, 2 with radius 2. And let's have point A inside, an arbitrary point C, which is inside the circle. So let's transform reflect about the circle. So we click on the object to reflect, that is point C, in our circle of inversion. And as you can see, we have there our C prime outside of the circle, and this is the image of our point C. When a point is inverted, it is reflected through the center of inversion and extended to intersect a circle or sphere. The resulting inverted point is located on the same ray but at different distance from the center. For the properties, points inside the circle or sphere of inversion are inverted to points outside. And this is case number 1. Case 2, inversion with a point on the circle or sphere of inversion. Going back to our GeoGebra, let's create another point which is on the circle. So let's have right here point D, and let's transform it. Reflect about a circle, so we choose point D on the circle, and of course our circle of inversion. So as you can see, from D it becomes D prime again, D, and then we inverted it, so D prime, it becomes D prime. So as you can see, the inverse is itself, or it is self-inverse. Points on the circle or sphere of inversion remains fixed. This is the property whenever we have a point on the circle. Case 3. And by the way, when a point is inverted, it remains fixed and does not move. This case is essentially a special case of inversion with a point inside the circle or sphere where the point being inverted is located at an infinite distance from the center of inversion. Let's have case 3, inversion with a point outside the circle or sphere of inversion. Going back to our GeoGebra, point A, and let's have it outside the circle. Let's see right here. So we have our point A outside the circle. Transform, reflect about a circle, so we click on our point E and our circle of inversion E. So we have here our point E prime, which is the image of E prime, translated or transformed to its inside our circle of inversion. When a point is inverted, it is reflected through the center of inversion and extended to intersect the circle or sphere. The resulting inverted point is located on the same ray but a different distance from the center. That is, its property states that points outside the circle or sphere of inversion are inverted to points inside. So if we have to put a line of the point to each point of like the image to be reflected in the inversion circle, it is always actually they are collinear with the center. Okay, so as you can see, D and D, there is also collinear. So actually it can be illustrated by just a point. Let's try to move. So right here from inside, we have reflected it to the outside, and if we try to move, as you can see, it moves. That when the two, okay, they have coincided right here, no, it means that it is self-inverse when a point is on the circle. And okay, so if we have see our pre-image outside the circle, the image will be inside of the circle of inversion. So let's explore more. Let's try to have an inversion, which is a line. What will be the image of a line? Letter A, a line second to the circle of inversion. B, tangent to the circle of inversion. And C, outside the circle of inversion. So let's try a second. Let's delete all the points first. Okay, so let's create a line which is second to the circle. So when we say second, it's a line that intersects the circle at 2 points. So transforming the circle by inversion, reflect about a circle. So we click on that second line in the circle of inversion, and you can see the image of that line is a circle passing through the center of inversion and to the points where our second intersected on the circle. Okay. Letter B, tangent to the circle of inversion. So let's have a tangent. When I say tangent, it's a line that intersects the circle at exactly 1 point. So it this line intersect at point D, where it is our point of tangency. So let's transform, reflect about a circle. We click on the tangent line and the circle of inversion, and there we have our image of the line, which is a circle passing through the center of inversion and also to the point of tangency. Letter C, we have a line. How about a line outside the circle of inversion? Okay, so let's draw the line outside the circle. Let's make it right here. Okay, and then reflect. So we click on the line and the circle of inversion, and we have there the image. The image of the line is a circle inside the circle of inversion, which passes through the point center of inversion. The next one, Let's illustrate a circle. What will be the image of the circle that is second to the circle of inversion, tangent to the circle of inversion, and outside the circle of inversion? So we are going to use the same circle, and let's create a circle second to it's a circle which passes through the circle at 2 points. So we have there. Then we have to transform. Click on our circle and the circle of inversion, and there we have a circle also that is second to a circle and second to the circle of inversion. Next, we have a circle tangent to the circle of inversion. So let's create a circle. Let's put it right here and tangent. Okay. Reflect. So we click on the circle of inversion. So we have an image here, a circle inside the circle of inversion, also passing through the point of tangent C. And letter C, the circle outside the circle of inversion. Let's have a circle outside, say right here. Okay, let's transform. Click on the circle and the circle of inversion, and as you can see, we have here an image created inside the circle of inversion. And that ends this video about inversion using GeoGebra. Thank you for listening.